Yes. Am I audible now?
Yes, sir.
Okay. So that link is faulty, what I have understood. In the morning also you could not join, now also. So I'll remove that link. I'll give you separate link so that from tomorrow you can join smoothly. Yeah. So 40 have joined.
Sir, your voice is too low to be audible.
Just a minute. Is it fine now?
No, sir.
Now?
Yes, sir.
Okay. So now is
Sir,
it
a
fine?
little bit more is required.
Now is it fine?
Sir, a little bit more is required.
Little bit more. Okay. Just a minute then. Just a minute. Am I audible?
Yes, sir.
Yes,
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 sir.
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 Yes, sir.
Okay, fine. So I believe I am loud enough to hear from you.
Yes, sir.
Okay, so let's start. So one thing, don't waste your time by writing anything. I will write, and then after the end of the class, I will send the transcript to you. That means whatever I write, I will post it in the Google Classroom so that you can download it. So no need to waste your time. Just try to understand. And if you have any doubt, so please stop me and ask. Okay?
Okay, sir.
Okay,
Yes, sir.
fine. So let me share my screen. Yeah. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So let me start. And just a minute. Let me join from another device so that I can see you. Okay, so you can see the screen now. Fine.
Yes, sir.
Yeah. So let us start. Let us consider any non-empty subset of R. Let A, which is non-empty subset of set of reals. Okay. A is said to be bounded above if there exists some real number alpha such that x is less than equal to alpha for all x in A. Is the definition clear to you?
Yes, sir.
You have a non-empty subset A of R. This set is said to be bounded above if there exists a real number alpha such that that real number is greater than equal to every element of A. And then this alpha is called an upper bound of A. Remember, this is called an upper bound. Okay, so if you have understood this, if I give you, this is my set A equal to, let's say, open interval 0, 1. You know what is open interval? Open interval 0, 1 means it contains all real numbers x such that 0 less than x and x is less than 1. So this is the setting. Okay. So can anybody tell me that this set is bounded above or not?
No, sir. It is not bounded above.
It is not bounded above. Why it is not bounded above?
Sir, because the
Yes,
set is
because
open.
yes, it is
No, no.
not
See,
bound.
one thing. Please try to understand. Please forget you know anything open, closed, etc. You simply forget. This course will be self-contained. Whatever we want, we will define it here, and then we will argue. Now, you assume that you don't know anything. See, whatever I have said, you need not assume that you know something. Simply, you know that what is the set of real numbers, that much I am assuming you know. What is a non-empty set, that much I am assuming you know. And what is the meaning of less than, greater than, etc. you know. These are the things we assume you to know. Means these are the things known to you. Now the question is, a set is bounded above if there is a real number alpha. Follow the definition and tell. If there is a real number alpha, such that every element of the set is less than equal to alpha, then alpha is said to be an upper bound of A. Now, with the help of this
No, it is
definition,
bounded.
is it not
So it is
bounded?
not
Bounded
bounded
above?
above. Just because we don't
Yeah.
have any
Bounded above,
upper
sir.
bound.
Yeah.
It is
So
bounded
can
above.
you? Yes. Can you give me an upper bound?
One.
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 One. What about two?
Yes, sir. Two,
It
three,
is also.
four.
Yes, sir. Yes, sir. 2, 3, 4, 5, etc.
Right. So you have understood that this set is definitely bounded above, and there are not only one, there are many upper bounds, infinitely many upper bounds. Right?
Yes, sir.
So this is bounded above. Yeah. This is an example.
So this is not clear to me.
Why?
So how can it be bounded above? Because there are many like boundary points like 1, 2. You told us right.
No, no. Again, you are using something that you already know. Why do you want to complicate your life? Boundary points, etc. We have not defined. Simply, I know that this is my set. This is my set. This is 0. This is 1. Right? All points which are greater than 0 and less than 1, these are the members of my set. Right? Yeah. May I know who are you speaking?
Sir Anisha Pal.
Annesha Pal. Okay. So see Annesha. In the set A, all elements between 0 and 1 are there. Now the definition says if you can find a real number alpha such that every element of the set is greater than equal to alpha, then your set is said to be bounded above, right?
Yes.
Yes. Now, is the condition satisfied here? If I give you, let's say 2, if I say 2 is equal to alpha, is it not alpha is greater than equal to every element of this set?
Yes.
Yes. So this set is bounded above. Now, is
Okay.
it clear to you?
Yes, sir. Yes, sir.
Yes. And not only this 2, anything you take, let's say this is 4. 4 is also an upper bound because every element of this set is less than equal to 4. 5, this is also an upper bound. 1.5, this is also an upper bound. 1 itself is an upper bound. But anything less than 1 cannot be an upper bound. Now the question is, what is the meaning of a set not bounded above? So I want to define this. A is not bounded above. Yeah, that is very good what Annesha did. If you have any doubt of any sort, please stop me and ask. A is not bounded above. Now I want to define this. Now can anyone help me? Yeah? Anybody?
Sir, 1, infinity.
No, no, that is not. Please try to understand what I am saying. My question is, already I have defined that when a set is said to be bounded above, A is said to be bounded above if there exists a real number alpha such that x is less than equal to alpha for all x belongs to A. That is the definition of a bounded set. Now I want to say that when this set is not bounded above, when this condition is violated, then it will not be bounded above. Now, what do you mean by the condition is violated? That is my question.
There is no such alpha such that every element of the set is.
Right, Rajarshi. No, you are?
Yes, sir.
Yeah. So what Rajarshi said, if there is no such alpha, but mathematically, how to write that? What is the meaning of there is no such alpha?
If
Means
al
if you
if
take,
alpha is if alpha is
yeah,
less than
Pratham, please.
if alpha is less than x,
No, no, no. Again, you have to be a little careful. See, what Rajarshi said, if there is no alpha, no such alpha, but mathematically there is no way to write that. So what do I do?
Sorry,
Yeah,
sorry if x tends to infinity.
no, no. See, what is tends to, I don't know anything. Strictly will follow strictly whatever we have defined. Right at this moment, all this tends to limit point, boundary point, closure, nothing, we don't know anything. Forget everything. We'll build it up. A is not bounded above means whatever alpha you give me, that will not work. Do you follow this?
Yes, sir.
Yes. That means mathematically I write that for every real number alpha, something should happen. Now, can anybody help me after that?
There exists a
Yeah,
element.
who is saying Rajarshi?
Yes, sir.
Yes, very good. So Rajarshi said there exists x belongs to
A
A such that
which is greater than alpha.
very good. Yes, Rajarshi, fine. Such that x is greater than alpha. So this is the definition. So this is actually the mathematical meaning of no such alpha exists. Whatever real number alpha you choose, I can always find some x inside my set which is greater than the alpha you have given me. So this alpha is not an upper bound. But which alpha? For every alpha this is true. So there is no upper bound. So this set is not bounded above. For example, if I give you this set, somebody told 0 to infinity, let me take this. Now this set is not bounded above. Why? Because you take any alpha, let alpha belong to R. Now in order to show that this set is not bounded above, you have to produce an element inside the set which is greater than alpha. Alpha is simply a real number I have taken. Now I will ask some of you, please don't answer. Whom I will ask, please answer. So let me ask somebody. Devapriya?
Yes, sir.
Yeah. Can you give me any element of this set 0 to infinity which is greater than alpha? Can you give me?
No, sir.
Okay. Then whom to ask? Juktamani?
Yes, sir.
Yeah. Can you give me any member of the set open interval 0 to infinity which is greater than alpha? No? Then Partha?
Sir, for every alpha there is exist a number which is greater than alpha
Yeah, that
or
is what
greater.
I want to know. You give me one particular element inside this set 0 to infinity which is greater than alpha. Can you give me?
Mm, infinite.
And infinity is not a real number.
Yes, sir.
Okay, please mute yourself. Let me ask
Sir,
somebody.
may I say?
Who are you?
Sir, I'm Bhaskar. Sir,
Bhaskar. Okay, Bhaskar.
alpha
Tell me.
plus 1, alpha plus 2.
Okay, just hold on. Yeah. What Bhaskar has said that alpha plus 1 or alpha plus 2. Okay, fine. Your idea is correct. This way only element is to be chosen. But Bhaskar, there is a slight problem. You do not know your alpha is positive or negative. Alpha is any real number. If alpha equal to let's say minus 100, then your alpha plus 1 is not a member of this set. Do you follow this? Do you follow Bhaskar?
Sir, more of alpha plus 1.
Yeah, very good. Very good. So that is the answer. Since alpha is a real number, so mod alpha is always positive. So mod alpha plus 1 will be an element of this set 0 to infinity, and mod alpha plus 1, you see this is strictly greater than alpha. Right? Very good. It proves that you give me any real number, I can produce an element inside the set infinity which is greater than that element. So I am through. This set is not bounded above. Therefore, this set 0 to infinity is not bounded above. Yeah. Now, like bounded above, I can define a set to be bounded below. So, a set A, of course, non-empty subset of R is said to be bounded below if there exists some beta belongs to R such that beta is less than equal to x for all x in A. Now, again, example, and in this case, beta is called a lower bound. Beta is called a lower bound of A. Yeah. So if I consider my A is again open interval 0, 1. Now let me ask somebody. Kavita,
Yes, sir.
is the set bounded below?
Yes, sir.
Yes. Can you give me a lower bound?
0, sir.
0. Fine. Very good. Please mute. Then Rejabul. Other than 0, can you give me another lower bound? Rejabul?
Hello, sir ji.
Yeah. Other than 0, can you give me any other lower bound?
Oh, sir, 0.
Yeah, 0 already Kavita said. Other than 0, any other lower bound? Acha. Okay, let me ask somebody. Shumita?
Yes, sir.
Yeah, any other lower bound other than 0?
Sir, -2.
Yeah, -2. Very good. -2, -3, all are lower bounds. So this is bounded below. Yeah, very good. Please mute. This is bounded below. Likewise, A is not bounded below, not bounded below when if no such beta exists. That means for every beta belongs to R, there exists an element X in A such that what? This X is strictly less than beta. Example, equal to minus infinity to, let's say, 1. Now I want to prove that this set is not bounded below. So let us take any beta belong to R. Yeah. Now I will ask someone whom to ask. Okay. Aditi.
Yes, sir.
Hello, Aditi. Can you hear me?
Yes, sir.
So can you give an element from Yes. Can you give me an element from the set A which is strictly less than beta? In the previous case, Bhaskar already answered. You have seen the trick. Now, can you give me a beta? Okay. Then please mute. Anesha?
Sir, mod beta minus 1.
Sorry.
Mod of beta minus 1.
Mod of beta minus 1. Yeah, so she said mod of beta minus 1. Yeah, but see the problem. You want to show that this should be strictly less than beta. Suppose beta equal to minus 500. This is a real number. What will be mod beta? Mod beta will be 500. And what will be mod beta minus 1? It will be 499. So do you feel that 499 is less than minus 500?
Oh, sir, so in this case, we will take only beta minus 1.
Yeah, but in that case, how do you know that beta is negative? Beta may be positive also.
Yeah.
So you do not know beta is negative or beta is positive, but one element you have to choose which work for both. So please think. Let me ask somebody else. Who? Amit Kumar. So this does not work. Any other element from the set which is less than beta?
Sir, I think 1 minus mod beta.
1 minus mod beta. Who said?
Sir, Bishmita Dhar.
Vishmitadhar. Yeah. See, mod beta, you always know mod beta is greater than equal to beta. So this minus of mod beta is always less than equal to what? Minus of beta. But what you know, you want to compare between 1 minus mod beta and beta. Which one is bigger, which one is less? Now the question is, beta, if it is positive, it may be positive also. If it is positive, mod beta is beta only. And minus of beta is definitely negative. If it is negative, then it must be inside the set. Now 1 minus mod beta, this has to be an element of this set, this, and this is definitely because mod beta is beta only. If beta is positive, 1 minus mod beta, this is nothing but 1 minus beta. And 1 minus beta is it less than beta? If beta is positive, yes, of course. Is it?
Yes, sir.
No, don't agree with me. You think. If beta is positive, can I say always 1 minus beta is less than beta? Suppose beta is 0.25.
Less than or equal to?
Suppose beta is 1 minus 25. Then what is 1 minus 0.25? This is 0.75. Is it less than 0.25? No. Are you getting this? So now the situation is like this. This is your set. So I request others also please think, and when I will ask, please answer. Minus infinity, so from the left side you can go anywhere. This is your 0. This is your 1. I have chosen beta. From where from I have chosen beta, I also don't know. Maybe beta is positive. Now, if beta is positive, anything you choose inside the set, that is definitely less than beta. No problem at all. The problem only comes if you choose something which is inside the set. If you take your beta, if beta is greater than 1, then you have no problem at all. Whatever element you choose from the set, that is going to be less than beta. Problem is, if beta is, let's say, greater than equal to 0 from here, but less than 1, then also no problem. Then I will take any negative number. Then also my job is done. Problem only lies in when beta is negative. If beta is negative, then something I have to choose which is less than beta. Beta is negative, you know. From here you have to take. So what you will take? You can take simply beta minus 1. Right? That's what who said just a few minutes? Bishmita Dhar. So what Bishmita said, if beta is negative, then beta is nothing but minus of mod beta, and take minus 1, that is going to be less than beta. Now whether this will work for everything, if any beta is given to you, can I say that minus of mod beta minus 1 is less than beta? Just think, if beta is positive, the problem is beta may be very large. So anything if you take, that may not help you. If beta is very large, beta is say 100, then minus mod beta will be minus 100. That will be inside the set. Minus 1, it is still inside the set, less than beta, no problem. If it is between 0 and 1, let's say beta equal to half, then minus half minus 1, it is still less than beta, no problem. If it is negative, minus of mod beta is nothing but beta, so beta minus 1 is less than beta. So the element is nothing but minus mod beta minus 1. Is this clear to all of you?
Yes, sir.
Yes. So given any beta minus 1, this element minus beta minus 1 is definitely inside this set minus infinity to 1, and minus beta minus 1 is going to be less than beta. Done. So that means no such beta exists which serves as a lower bound. So this set is not bounded below. Okay. Now, next thing is, suppose A is a set A. I know that A is bounded above. A is bounded above. What can I say about this set minus A? What is minus A? Minus A means the set of all Y belong to R such that there exists some X in A such that this Y equal to minus X. The meaning is it contains all minus X such that X belongs to A. This is the set. What can I say about this set? I know that A is bounded above. So what can I say about minus A? Can anyone give me the answer?
It is bounded below.
It is bounded below. So Prashanta has got the answer. Yes, it is bounded below. I agree. How to prove that? So this is our first result, I can say. So let me write it formally. Let A be bounded above then minus A, which contains all elements of the form minus x, where x belongs to A, is bounded below. Let's try to prove it. So now you will see how to write a proof. See, what is given to be proved? You want to prove that a set is bounded below. That means what do you want? You want a lower bound of the set, right? Yeah?
Yes, sir.
Yes, sir.
Now, where from that lower bound will come? That lower bound will come from upper bound of A. So let us try. Since A is bounded above, so what happened? There exists a real number alpha such that something should happen. What? For every x in A, x must be less than or equal to alpha. This is correct. This
Yes, sir.
implies for every x in A, minus x will be less than equal to minus alpha. Yeah. If I multiply by minus 1, then inequality will be changed. Now I have something in my mind that this minus alpha will be a lower bound of the set minus A. But how to prove it? For that, I have to show that every element of minus A is greater than equal to minus alpha. So let me take any element in order to see, this is a trick. You should see it carefully. Whenever you want to prove that every element of a set satisfies some property, it is enough to show that it is satisfied by an arbitrary element of the set. You take any arbitrary set and prove that, take any arbitrary element and prove that that particular element satisfies the property. So it will be satisfied by each and every element. Do you follow what do I say?
Yes, sir.
Yes, sir.
Yes.
Yes,
So
sir.
take any element. Let y belong to minus a. But if y belongs to minus a, just above I have defined, minus a will contain all real numbers y such that there exists some x in a such that y is minus x. That means there exists x belongs to a such that y equal to minus x. But already you have proved that for every x, minus x is greater than equal to minus alpha. So this is greater than equal to minus alpha. Now I have proved that you give me any element from minus a, it will be greater than equal to minus alpha. Therefore, minus alpha, or directly I can say, therefore, minus a is bounded below. Now, and we have understood another thing, that if alpha is an upper bound of a set, then minus alpha is a lower bound of minus of that set. So this is something important we have learned from this proof, that alpha is an upper bound of a set A. This implies minus alpha is a lower bound of minus a, and vice versa. You can try to prove that if you start with minus alpha is a lower bound of minus a, you can prove that alpha is an upper bound of a. This is simple. You can mimic the proof. You will get it. Yeah. Now, next, you have two non-empty sets. Suppose A is a non-empty set, subset of R, and B is another non-empty set, subset of R. Yeah. I know that A and B both are bounded above. So alpha is an upper bound of A, beta is an upper bound of B. Now, what happens to this set? A plus B. What is A plus B? A plus B contains all elements Y in R such that there exists small a in capital A and small b in capital B such that Y equal to A plus B. Now, is this set bounded above? Yeah. Whom to ask? Tanvir Majumdar. Yeah, Tanvir, can you hear me? Tanvir? Okay, he's not replying. Yuvraj, can you hear me?
Yes, sir.
Yeah. What happens to A plus B? Is it bounded above?
Sir, bounded above, sir.
Yeah. Can you give me an upper bound of this?
Hmm.
Okay. Then
Sir,
any upper bound?
So may I say?
Okay. Okay, just a minute. I'll ask. Then whom I have not asked? Sharvani? Sharvani, can you hear me? Hello? I think she has some problem. She is not audible. Rajarshi?
Yes, sir.
Yeah. So A plus B, is it bounded above?
Yes, sir.
Yes. Can you give me an upper bound?
Alpha plus beta.
Alpha plus beta. Okay. Very good. Please mute. So what Rajarshi has suggested, if alpha is an upper bound of A, beta is an upper bound of B, then alpha plus beta is an upper bound of A plus B. The proof is very simple. What to do? You take any element from A plus B. Let Y belong to A plus B. What does it mean? This implies there exists small a belong to capital A and there exists small b belong to capital B such that what happened? Such that Y equal to A plus B. But already you know that alpha is an upper bound of A. That means any element of A, capital A, is less than equal to alpha. And small b belongs to capital B. Beta is an upper bound of B. So any element of B is an equal to beta. So already you know that this is less than equal to alpha plus beta. That means whatever Y you choose from A plus B, it must be less than equal to alpha plus beta. Therefore, alpha plus beta is an upper bound of A plus B. Okay. Next, suppose A is a set, non-empty subset of R. And this is bounded above, bounded above. Suppose alpha is an upper bound. This is also given to us. Upper bound of A. Now C is a real number. I denote CA equal to the set of all real numbers y such that there exists x from A satisfying a property. What is that property? That y must be equal to C times x. So this is my set CA. Now, can anybody tell me? Okay, let me ask. Rajashri, is this set bounded above?
Uh,
No, not Rajashri, Rajashri.
Yes, sir.
Is this set bounded above? Yes? Not confident. Okay, then Manjita, is this set bounded above? Hello? Then Labib, is this set bounded above CA? Devashish Datta,
Yes, sir.
is this set bounded above CA? Okay, Bhaskar,
Yes, sir. Absolutely, it is bounded above.
it is bounded above. Okay, can you give me an upper bound?
Yes, sir. One of the upper bounds we can give as
Hmm.
C into alpha.
C into alpha. Okay, so Bhaskar said that it is bounded above. So let me consider my A equal to, okay, let
Or
me use,
CX
oh,
CX plus 1.
no, fine, Bhaskar. Okay, let me show you. You please mute yourself. So let us take any set A. Suppose this set is our known set, this open interval 0, 1. And C is a real number. Suppose you know that this is bounded above and you know suppose alpha equal to 2. This is an upper bound. Suppose C equal to minus 1. Then what is CA?
minus
Minus,
1 to 0.
yeah, minus 1 to 0. So it is bounded above, still it is bounded above. But see, what Bhaskar has said that C alpha will be an upper bound. That is not, because C alpha is minus 2. Okay, fine. In this case, you are safe. But if I take my A is, let's say, minus infinity to 0, this is bounded above. And if you take alpha equal to 1, this is an upper bound. But again, if C is minus 1, then if C equal to minus 1, what is CA? CA is 0 to infinity. This is not bounded above. So simply given a real number C, one cannot say that CA will be bounded above or not. You should know that whether this C is positive or negative. Unless you know the nature of C, we cannot say anything. Yes, according to Ashkar, whatever he said is correct if C is positive. So our conclusion is This is bounded above. This is bounded above if C is greater than equal to 0 and it is bounded below this is bounded below if C is strictly less than 0. Is this clear to everyone? Please tell me if you have any doubt. If you don't say anything, then it will be assumed that you have understood. If anybody has any confusion, please tell
Sir,
me.
C is finite or infinite?
C is a real number. Can real number be infinite? A real number is always finite, no? C is a fixed real number. It may be minus 5 crore. It may be plus 10 to the power 10 crore. No problem. It's a real number only. Yeah. Do you follow this? That if C is negative, then the set is bounded below, but not necessarily bounded above. Just like you have proved if C is minus 1, then minus A is bounded below. Any confusion? Okay. So similarly, whatever we have done, we can apply the same thing for bounded below sets also. Right? In this case, suppose alpha is an upper bound of A. If C is greater than equal to 0, then whatever Bhaskar said is correct. C alpha is an upper bound of A. But if C is negative, then can you give me a lower bound of CA? Anybody? Rajarshi? If
Yes, sir.
if C is negative, can you give me a lower bound of
C alpha.
C alpha? Is it? In case of minus A, if alpha is an upper bound of A, then what is the lower bound of minus A? We have
Alpha.
evaluated.
Minus alpha.
Alpha.
Minus alpha. So
Minus alpha. Okay.
in this case, minus C alpha will be a lower bound definitely. So minus C alpha is a lower bound. So this much only we can say. Now enough we have said about bounded above, bounded below. If a set is both bounded above and below, it is said to be a bounded set. So this is the definition of bounded set. A non-empty subset A of R is said to be bounded both bounded above and bounded below. So if a set is both bounded above and below, then it is said to be bounded. Okay, in B.Sc, have you seen the definition of a bounded set? Yes?
Yes, sir.
Yeah. How did you define bounded set?
So same only. If the set is bounded above and bounded below, the set is called bounded.
Yeah, right. But any other definition have you seen that there exists m greater than 0 such that mod x is less than equal to m for all x
Yes,
belong
sir.
to the set? Yeah, have you seen?
Yes, sir.
Yes. So just let me say a few words about it. If A is bounded above means it is both bounded above and bounded means it is bounded above and bounded below. That means there exists alpha and beta, two real numbers, such that for all x in A, x must be less than equal to alpha, and at the same time for all x in A, x must be greater than equal to beta. So that means for x belongs to A, beta should be less than equal to x and x should be less than equal to alpha. Now I want a single positive real number m such that mod x is less than equal to m. Now what is that? If you see, here is alpha, here is beta, and all elements of the set are in between. Now can you give me one particular m such that mod x is less than equal to m for all x in A? Is it possible? Can you give me one such m?
Sir, maximum of mode alpha comma mode beta.
Maximum of mod alpha comma
Mode
mod
beta.
beta. Is it? Suppose, just check, what is the meaning of mod x less than equal to m? That means your x should be less than equal to m and minus x should also be less than equal to m. Now, who has said this maximum of mod alpha mod beta?
Prashantanath.
Prashantanath, yeah. So let's see what Prashanta has said is correct or not. Let us verify. So Prashanta said m equal to maximum of mod alpha and mod beta. Let's check now. Take any x from A. Yeah. If x belongs to A, then you know that x is less than equal to alpha. Then x is less than equal to alpha. Alpha is always less than equal to mod alpha. And mod alpha is less than equal to m. Because m is the maximum of mod alpha and mod beta. So it has to be greater than equal to mod alpha. What about minus x? See, from here you know that for all x, x is greater than equal to beta. So minus x will be less than equal to minus beta. Then minus x is less than equal to minus beta. And minus beta is less than equal to mod beta. And mod beta is less than equal to m. So my job is done. I have got that given any x in A, x is less than equal to m and minus x is also less than equal to m. So mod x must be less than equal to m. So what Prashanta has said is absolutely correct. One such m will come by taking maximum of mod alpha and mod beta. And this is the proof. Is there any doubt from anybody? Okay, if there is no doubt, then I think this is the right time to stop. But again, let me tell you, whatever I have done, the transcript, I will upload in the Google Classroom. Please download it and go through whatever I have done today. This material, the best book will be this Basic Real Analysis by Ajit Kumar and Kumaresan. You can download it from that website I told you, LibGen. So you download the book, you go through the content, you just think whatever we have discussed today. If you have any doubt, please feel free to write it down on the Google Classroom itself, or you can ask me in the next class tomorrow. I'll create a new link. The old link, it seems to be a problem, so I'll not use it anymore. I'll create a new link I'll share with you tonight, so that from tomorrow onwards, we can have our classes seamlessly. So, do you have any question to ask me?
Class.
Sorry?
So tomorrow at what time you will have a class?
I have to check somehow. It will be either from 11 or 12, but I'll check and I'll let you know. Do you have any class tomorrow? Have you
So
got
based on the routine, Venkatrao sir will take our class, and the other teacher did not inform us whether they will take our class or not.
okay? At what time Venkatrao sir will take?
So I need to check the routine.
Okay, fine. Anyway, I'll check when the Venkatrao sir's class is there. So I'll shift it accordingly and I'll let you know tonight itself. It will be posted. So that way there is no problem. Okay, so if there is no question from your end, I'll stop now and we'll meet tomorrow. So thanks for your patient hearing and please feel free to ask me questions. If you have any doubt, you can